Thevenin problem to work on here, and let's find the current through RL. Let's find the current through RL. So what we'll do, again, follow the steps of Thevenin's theorem. We'll remove RL. And now solve for certain parameters, right? Now, if it had said find the voltage Thevenin, well, that's part of the process, right? If it said find resistance Thevenin, again, it's part of the process. So don't get freaked out if you see a question like that. Now, to start to solve this, what we've got here is a parallel branch, a parallel source, and another parallel branch. Is that anything different than what we've dealt with so far when we were dealing with the parallel lesson? No. And in terms of finding voltage Thevenin, what voltage, what resistor could I use? Would be the easiest one to go with. R4, right? Because I just want to go A to B. So I'm going to go out A, across R4, back to B. So I only need to find the voltage drop of R4. I don't have to solve for much of anything else for voltage Thevenin. So let's go ahead and do that. In this branch here, I've got 1K in series with 3K. There's my source, that's 12 volts. In this branch here, now look, this forms its own branch right here, right? So don't get confused with the load resistor being pulled out, thinking, oh, I don't know how to redraw that. All this is a series branch. 2K plus 4K is 6K. Now I'm just looking for the current through R4, right? Well, isn't R4 in series with R2? So I want the current through this branch. The resistance of that branch is 6K, is it not? Can I find the current through there with the 12 volt source? Yes. Parallel? It's going to be what? 2 milliamps, right? 12 volts divided by 6K is 2 milliamps. So I've got 2 milliamps going across R4. What voltage drop does that give me for R4?
Day number 6 already have 2-phase, 1 dipole.
8 volts. And lastly, what's the polarity? Which way is current going? Current is going up, right? It's going that way. So I've got negative and positive. Let's go A to B. A, positive, 8 volts, B. So what's my voltage Thevenin? 8 volts. Any questions on that? This problem right here is very similar to one you might see on the exam, and it throws a lot of people off because they can't digest the fact that this is a series branch. And then on top of that, they waste a lot of time finding all the parameters, but looking for voltage Thevenin, when all they need is R4. Don't fall into that trap. Next, we'll look for resistance Thevenin. We start out again at A. We come out of A, we hit a node. We go right, we hit R4. We go left, we hit R2. And then we hit a node. We go down on that node, we hit ES1. We're going to short around it. We go continue left on the node, we hit R1. Then we hit the top of R3. Then back down to this node, we hit the negative terminal on the source and bottom of R3 marry up together. At that node, and then this node and the bottom of R4 marry up together. And then back to B. All right, let's add up our total resistance. This is a short through here, is it not? 1.3K. If this is a short, this is a short along this path right here. Will this R1 and R3 come into play at all? No, they will not. Okay? Therefore, this resistance value will be ignored, and you'll be left with R2 in parallel with R4, which we said was what? You just figured it out? 1.3K. So our resistance Thevenin, 1.3 K ohms. First things first, total resistance is 2.3K, giving us a total current of
3.5 milliamps.
3.5 milliamps. So when we put RL sitting at 1K back in here, I know. We get 3.5 milliamps going up across it, and then from there we can also find our voltage, yes? Just ignore this stuff over here, that only applies to the voltage step. Now, one other application of this, just a real quick note. If I've got 3.5 milliamps across the 1K ohm resistor, what's my voltage there? 3.5 volts. If R4 is in parallel with R1, it is, yes, RL rather, then this has also got 3.5 volts, right? So can I find the current across this? If I can find the current across this, and I know the current across that, they add this node here, right? So then I can find the current across R2. If I can find the current across R2, then I can find the voltage across R2 and add it to this 3.5 volts here, and it should equal what's at the source. Then again, I could also just subtract it, being how it's in series with R2. Okay, so we see how we can find a bunch of different things there, yes.
Why would that 12 volts for the trailer?
What's that?
Why would that 12 volts go over your R?
Because of R2. It's got to go from here to here because R2 is in series with that. Okay, makes sense?
That doesn't